Alright, and so we're continuing our work with radicals, and we're going to talk about simplifying more complex radical expressions. And so to do that, we need a couple rules, and this really comes from the rules of exponents. So product rule for nth roots, so we have the radical of the nth radical of, or nth root, if you will, of AB, and what we can do is split that up. Now, if you remember from exponents, we actually had if we had a b to the nth power, we could actually write that as a to the n times b to the n. Same thing, n here is just a rational function, and so remember the analog of this one would be ab to the 1 over n power. We could write that as a to the 1 over n times b to the 1 over n. Same thing. Quotient rule, really it's the same idea here, is if you have the nth root of a quotient, you can split that radical up and apply it to the numerator and denominator for the same reasons as all this up here. Okay, so radicals, exponents, same ideas, just communicated differently because we have a fractional exponent. Alright, so let's go ahead and look at some examples. We have the square root of 288. Well, 288, I don't know how to, if I punch that in my calculator, I'm going to get a decimal. Okay, so it doesn't, there's not a nice number that we get as a result. So what I'm going to need to do is leave it in exact form, which involves roots. Alright, so when I do that, let's just kind of factor this and see what falls out. So I have the square root. 288, I know that's divisible by 2, so it's 2 times what number? Well, if I divide everything by 2, I get 2 times 144. Okay, 144, I know is a perfect root. In fact, 12 times 40, or 12 times 144, or 12 times 12 is 144. That's what I meant to say. So now let's go ahead and break this up using the product rule. I can write this as the square root of, let me redo that, the square root of 2 times the square root of 144. Alright, and so the square root of 144 is 12, so I can write this as square root of 2 times 12. And typically when we communicate this, we put the whole number out front and we follow it by whatever the radical is. So same idea, I'm just communicating it differently. And so that's the answer. Okay, and so the answer in exact form would involve roots. Sometimes you may be asked to give the answer in decimal form, in which case you have to, punch it in your calculator, get out a number. But an exact form should involve roots. Now this one, same idea. Let's go ahead and split this up. So I'm going to break it up right away. I have multiplication in between, so I have the cube root of 432 times the cube root of x to the 5th. Okay, so I need to think about how does 432 factor? And I'll deal with the x to the 5th momentarily here. So this is the cube root of, well, I know 2 goes into it, so I'm going to do 2 times 216. Okay, that's what I get when I divide that by 2. And this is now the third root of x to the 5th. Okay, 216, you can continue to divide it and everything, but what this is actually going to end up being is the cube root, let's see, 216 is 6 cubed. Okay, so, but you can maybe pause the video and continue to factor it as you need to. Now, what this says is I have 5 x's all being multiplied together, and for every 3 I can pull out 1. So what this is going to be is I'm going to pull out an x. So this is really 3 of my x's, and then underneath the cube root I'm left with x, with 2 x's being multiplied together, so that's x squared. So that's how I simplify that. And now this, the 6 comes out front because I have I have 3 of them appearing. So this is 6 times the cube root of 2 times x cube root of x squared. Okay. Now since I have multiplication, I can just multiply everything that is outside of the radical together, meaning I can multiply the 6 and the x together, and then I can also multiply everything that's underneath the radical together. Okay, and this is all due to this operation here. If I did not have multiplication, I cannot do it. Okay, and we'll talk about that momentarily here. Alright, so my final answer is going to be, I've multiplied the 6 and the x together, I get 6x. Then I have the cube root. Okay, and now I have to multiply the two things underneath the radical together, and I get 2x squared left over. So, what did I do? I broke it up using the product rule. Okay, broke it up. Factored this and left this alone. Saw that 216 was 6 cubed, and then I simplified this over here. I had 5 x's being multiplied together. I could pull out 3 as 1 because I had the third root. That's done here. I had 3 6's, pull one of them out since I had a group of 3 and the third root, and I'm left with this, and then simplify from there. Okay. Last idea in this section is that you have to add and subtract radicals. Okay. This is just like adding and subtracting variables. So, for example, if you have 2x plus 3x, well, this is, you have like terms, so you can just add them, 5x. But if you have 2x plus 3x squared, that is not equal to 5x squared. Okay, you can't add them right over, or this would actually be x cubed. Okay, you can't add these because we don't have like terms. We have x and we have x squared, and those are different. Okay, so let's take this one step at a time. I have 4, and maybe I'll hide the other one quick. Okay, so I have 4 cube root of 56 minus 2 cube root of 7. Alright, so this 56 I can factor as, let's see, this is going to be the third root of 56 is 8 times 7. This is multiplication, minus 2 cube root of 7. Okay, this 8 is a perfect cube, meaning that that is actually 2, so I can pull out that's 2 cubed, so I can pull out a 2, and that comes out as multiplication. So this is 4 times 2 times the cube root of 7 minus 2 cube root of 7. So 8 minus 2, the cube, now I have, let me write it out. So this is 8 cube root of 7 minus 2 cube root of 7. Okay, now I do have like terms. This and this are similar. So this is more or less 8x minus 2x. And when I do that arithmetic, I just get 6 cube root of 7 as my result. Okay. Same idea, but now we have multiple variables. And so it's not necessarily harder, it just might take longer. Okay, so I have a square root, square root, square root, and I have fractional exponents. Okay, so this is going to be fun. First, let's just simplify everything inside of a radical that we can. So, let's see, I have 14x squared. Now I have 3x y to the 9th. Alright, so what this is saying, for every 2 of an object, I can pull out 1. Alright, so here I have 8. I have 8 plus 1. So here I have 4 complete sets of 2 y's being multiplied together. So that comes out as y to the 4th. And then what am I left with? I'm left with the square root. 3 I can't pull out, x I can't pull out, and I'm left with y. So what I did was I separated this into y to the 8th and y. And then as I had a square root, I had 4 complete groups of 2 y's being multiplied together, and so for every 2 I can pull out 1, and I ended up being able to pull out 4 of those y's. Next term. Okay, so 2y to the 3 halves. That's left out front. Here, let's go ahead and break this up a little bit. So I'm going to have the square root. I think the easiest way to split this up is going to be to do a 3 and a 16. You could also do 6 and 8 or 4 and 12. You'll just have to maybe do some more steps. So I'm going to do 3 times 16, x to the 5th. Okay, I need to break it down into 2's. So I'm going to have an x squared times an x squared. Okay, so I'm looking for any multiples or 2 of a given thing or a given term being multiplied together. So I have x squared, and x. Y to the 6th, that is y y squared times y squared times y squared, all underneath the radical. Okay, and now I'll break this one down a little bit slower as well. So this is going to be, let's see, 7y to the 9 halves, and then square root of 108. Okay, and then I have underneath the radical, 108 is going to be 4 times 27. Okay, and then times x squared times x squared. Okay, again, I'm breaking it down into things that have 2's in them. Alright, so this first term I can't really do anything with. So I have 14x squared y squared square root 3xy. Next term. Okay, so now this is going to be a little bit of a long process. So I need to look for anything that I can pull out 2 of. So here, 3 I can't pull anything out of, so that's left underneath the radical. Okay, 16, that is 4 times 4, so I can pull out 1 4 and multiply that times 2, so that I get out an 8 when I simplify this term. Looking at the x's, I have x squared, so I can pull out 1x. I have another x squared, so I can pull out another x, so I pull out an x squared. Okay, and then this remaining x I just leave. Alright, so last thing is the y's. I have 3 y squareds. So that means for each y squared I can pull out a single y. So I pull out a y squared, y cubed. So I pull out a y cubed in total. So I have y cubed, and then I have a y to the 3 halves. Okay. We'll talk about this term. We have to do one more step with it in a minute here. Last term. 7y to the 9 halves. Okay, great. So this is minus, not equals, minus. Here I pull out a 2, so that, and 27 I can write that as a 3 and a 9. So I can actually pull out this 3 I can't do anything with, but this 9 I pull out another 3. So I pull out a 3 and a 2. So 3 times 2 is 6. 6 times 7 is 42. And then I have 2x squareds, so I pull out an x squared as a result, an x for each of those, and I'm left with y to the 9 halves square root of 3. And I don't have time to finish this example, but what I did with the second term was split up this into y and y to the 1/2 and rewrite it. This one I did the same thing, split this into y to the 4th and y to the 1/2, and this is your final answer. So that's a brief example of simplifying radical expressions.